there's potash as well. I thought I'd just show you guys probably a little bit different than what you're used to, but I'll carry my computer over my window here just so you can see what I get to look at every day. Probably a little different than you guys. We get snow 6 months a year here. So today we're going to discuss disposal wells. My background, as discussed, was I've dealt a lot with disposal wells in my career, both on the oil and potash sides. I'm going to run today pretty much through everything, right from basics of designing a well all the way to one of the that way you get a whole feel for how disposal wells work. So, well, one of the things that's going to affect things, and I guess before I start, I'm going to talk for 5 to 10 minutes, and then I'll take questions. If you guys could type your questions into the chat, that'd probably be the easiest way to do it. So I'll talk 5 to 10 minutes, and then we'll do some questions, and then I'll go kind of on to the next topic. So when looking at a disposal well, the drilling of it is obviously kind of key to it. One of the first things you'll learn about disposal wells is that the drilling mud used for a disposal well is going to be important and is going to affect your disposal well down the road. Kind of how you obviously drill a disposal well is you have pipe with a bit on it. Now, when they first started drilling wells, they used cable tools where you have a piece of pipe on the end of a cable, you drop it down and collect the chunks you were breaking in the bottom of your hole and lift it out and empty it out. When they moved to pipe drilling with a bit on the end, that made things quicker and easier. Obviously, you can rotate the pipe, and with the bit on the end, you can break up the rocks at the bottom of your well. And obviously you inject fluid down your drill string to come out your bit and back to surface. Now the purpose of your drill fluid is there's a couple things it does, but one of the first things it does is it carries your chunks that you're breaking of rock to surface. So it gets them out of the hole. Now, one of the first drilling fluids they ever used was water because it was cheap and readily available. The problem with using water as a drill fluid, or just water as a drill fluid, is you have troubles. Water doesn't carry rock chunks to surface all that well. Rocks are heavy and water doesn't carry stuff all that well. So they started adding stuff to the water to help carry it. So you add some stuff to the water that adds viscosity that will help lift your rock chunks out of the well. Now, the other problem with water is when you're drilling and you hit a zone that is porous, so something like a sandstone, your water, instead of coming back to surface, it's going to travel out into your zone. Now, the stuff you add to help lift it to surface has a second purpose, and that is to seal off this zone because you don't want to lose all your drilling fluid into your formations as you're drilling. So what happens is as your fluid is getting pushed into your formation, you've added stuff to your water that adds a film, or it won't go through the porosity, so it creates a film. So your fluid, your water portion enters, but your solids pile up on your formation and create a film so that you don't lose your drilling fluid into your porous formations as you're drilling. So drilling fluid down the road is going to make a big deal when it comes to your actual disposal formation, because obviously your disposal formation you're going to drill through and you're going to leave this film on over top, which is going to restrict how much fluid you can inject into your formation once you get there. Does that make sense to everyone? Does anyone have any questions about that? Okay, so when you actually come to drilling or designing the disposal well, in Canada at least, you have to drill a casing string across your freshwater formations at surface. And the reason for that is at least in Canada, if you ever contaminate your freshwater zones, the offsetting farmers and landowners that use the freshwater will be very mad at you. So what we started doing was landing casing across your freshwater zones just as extra protection. Now we're gonna go with the easiest case. You're gonna land a casing string down either across your disposal zone or open hole across your disposal formation. Now, the reason you go open hole or run your casing, cement it, and then drill out and run a liner across your disposal formation really comes down to the thickness of the formation. So in a thin formation, to do an open hole completion really doesn't make any sense. It would cost a lot of money. Whereas in a thick formation, something that's hundreds of meters thick, it's a lot cheaper and easier to drill down, case your hole, and then drill out into your formation and then just run a liner. So there's no cement, there's no nothing. All you've got is formation behind here. So really it comes down to thickness, because perforating, when you case your zone across your disposal formation, you're going to have to perforate, set off explosive charges to make it through your casing into your disposal zone. If you have a thick zone, those perforations cost a lot of money, and it's easier and cheaper in a thick zone just to run your liner across your disposal formation. Now, what I was talking about before with the drilling mud is, remember, you drill out across this formation, and what you're going to leave is a little film across your disposal formation. Now that's when you actually get to injecting. If you're trying to push water into here, you're going to be left behind with a little film that's going to prevent you from pushing your fluid, pushing your disposal water into the formation. And you're going to have to deal with that. Now, even if you case it all the way down and cement it and then try and perforate through, you're still going to have this film across, and you may or may not be able to get past it. So that's one thing to worry about. You're going to have to do something about that at the tail end, and depending on the type of formation you have, you might do different things to it. Some of those things you might do is, if it's unconsolidated sand, like we have around Lloydminster, you can just do a foam job where you pull a lot of fluid out of the formation, and with that will come the sand because it's unconsolidated. If you have a consolidated formation, you can frack it, might be the easiest way to get past this damage so that you get good access to your formation. Does that make sense for everyone? Anyone have any questions on that? All right. The other thing that I didn't cover when you're in the drilling process, and the most important part when it comes to drilling, or the thing that's going to give you the most problems, is the actual cementing of your casing. So you get your hole down to where you want it. And you run your casing inside. So now you have your casing inside your borehole. When it comes to the actual cementing of it, that is the most important part you'll have, whether it's a disposal well or your cement is going to make or break your well. And any problems you're going to have with your well are going to totally rise cement. And the reason for that is you only get one shot at cementing. So if you go to cement and something goes wrong, you can't do it over again. Even if you know that you're having problems while cementing, you can't change on the fly. You're pretty much set on what you're going to do. So once you start cementing, you can't stop, and you just have to go ahead with the job. Now, the other problem with cement is before you go to cement, you're going to have drilling mud in your well bore, and your pressure applied to your well bore is going to be a rho GH. So gravity, height, and then your density of your fluid. So your density for your mud might be, let's say, 1,200 kilograms per meter cubed. Your cement density is a lot greater than that. So your density, so this is for your drilling fluid. Your density for your cement might be something like 1,800 kilograms per cube. So when you look at the difference between your drilling mud and your cement, all of a sudden you're adding a lot more pressure. And if you go to cementing, applying that much more pressure, to have more cement leak off because you're applying more pressure is a real issue. So your cement leaking off would be a real issue, and you only get one shot at it. So to limit your risk, what I actually like doing is adding a little bit of lost circulation material to the cement, just in case you lose. That way it seals off wherever you're losing from, and you actually get a good cement job because you only get one shot at it. And for a disposal well, it's actually more problematic if you have a bad cement job. In Canada, what they require is testing after the well is complete to make sure that the fluid you're injecting or disposing of is staying within your disposal formation. So if you have a bad cement job and the fluid you're disposing isn't going into your disposal formation, but rather migrating back up the well because you've got bad cement, what the government will require us to do is remediate that. So perforate, cement squeeze, just to make sure that you have isolation of your disposal zone. Having holes in your casing is problematic long-term for when you're disposing. On the completion side, so that covers off why the cement is important. And what happens if you have bad cement, essentially. When it comes to the completion of the well, so you got your casing inside the well. On the completion side, you're going to run an injection string with a packer on the bottom. So what a packer is just a tool with a rubber element. So it's hollow in the middle. I just got a question about the cement. So to reinforce the cement, material is injected. What was that again? So what you can do with your cement, the real risk with your cement is because it's such a higher density, it applies a lot higher pressure on your formations when you're cementing. And the risk of losing your cement is higher because of that. And if you lose a little bit of cement and you don't get cement to surface, then you're going to have problems. So what you can add to your cement is a little bit of lost circulation material. So what lost circulation material is, there's a bunch of different things they use, but fiber would be considered lost circulation material. All lost circulation material is to, if you start losing cement, it just plugs whatever you're losing to. So they use sawdust would be considered a lost circulation material. Fiber, anything that's granular so if you start losing cement out here, whatever the solid pieces, the sawdust, the fiber would actually, as you're losing the cement, it can't pass through the small holes that the cement is, and it just packs off to prevent losing the cement into the formation. there any other questions about that? Okay. Now that's not I won't say that's a common practice. It's not at all, because everybody wants to drill the cheapest, easiest wells they can. So they opt for the easiest, cheapest techniques. I use this just as kind of a cheap fail safe on the riskiest part of drilling the well. So when you drill a well, you're trying to minimize your risk and maximize on an oil well productivity, or on a disposal well, you want to maximize your injection rate. Those are your two biggest, if you can minimize your risk. Everyone thinks minimizing cost is the biggest thing, but really you want to minimize risk, because having something cost a little bit more, but save you the headaches of having a bad cement job, for example, that's massive. I've been on jobs where we've completed the job, found out that we had cement leak off, didn't get a good cement job, had to perforate, cement squeeze, drill out, and then have problems with the disposal zone afterwards because of that. And it is a complete and utter nightmare that causes a lot of stress. Something like adding just a little bit of lost circulation material to your cement costs a little bit of money, which lots of companies get worked up about, a little bit of money spent. But if you can save stress on the back end, and it's not going to happen on every job where you have cement problems, but saving some problems on the back end on 1 out of every 5 to 10 wells, let's say, just saves everyone a lot of headache and hassle. Like I said, the riskiest thing you do in your whole well is going to be your cementing, just because you get one shot at it. With everything else, if you have problems while you're drilling and you, let's say, have a mud ring, or you get stuck, or those things, you get more than one shot at. So if you have a problem, there's always something you can do. The problem you have with the cement is you get one shot at it. You cement one time. And if you don't get the cement job right, and it can be totally out of your, it's not your fault that you have the cement doesn't work out as well as what you want. But if you can prevent those problems, those unknown problems arising, then it just makes the job go smoother, and you don't have a bunch of headaches down the road to deal with. So on the completion side, you're going to run an injection string with a packer. Like I said, the packer is hollow in the middle, so you can inject through it. And on the outside, it has a rubber element that expands. So you run your injection string, and then on the bottom, you expand the element to seal. So now all of a sudden, you've got what you're doing with your injection string with your packer is protecting your casing. So an injection well, you might be injecting corrosive fluid, you're injecting lots of water, which can add to corrosion. What you're trying to do with the injection string and the packer is protect your casing string, because it's something that can't be removed from the well. And the longer you can keep your casing string good, if you get a hole in your injection string, let's say, no problem, pull it out of the well, run a new one, not a big deal. You have a problem with your packer, pull it out of the well, run a new one, no big deal. You have a problem with your casing string, well, now you've got problems. Let's say you have a hole in your casing string. Well, now you've got bad options to figure out what to do with it. Because anything you do here, you're going to have to run, let's say, either a whole new casing string inside this and cement it into place, or run a patch across your hole. Well, both those things restrict your ID that you're working with, and which means you're going to have to restrict the size of your injection string. The larger the injection string, the more water you can inject, which is what a disposal well is for. If you have to make your injection string smaller, all of a sudden you're going to be able to inject less water, essentially due to friction pressure. The larger the pipe, the higher you can pump higher rates before friction pressure causes you problems. With a small string, your friction pressure gets higher quicker. So if you have a hole in your casing, that is the biggest problem you can have. So running an injection string with a packer is going to keep your injection rates up higher for longer. Does that make sense? Anyone have any questions on running an injection string, or why you'd run an injection string with a packer on the bottom of it. Okay, so you've got your injection string, you've got your packer. I've got a mess on my board. Okay, so let's assume we've got a thick zone, let's say 100 meters thick. We've drilled down to the top of it, run our casing string, cement it into place. You drill out, drill down to your bottom of your disposal zone, and then you run your liner with a liner hanger. Now, the purpose of the liner with the liner hanger is the liner piece of pipe, you can either run slots or holes. With the liner in the oil industry, when you're producing oil, you run slots. Now, the reason you run slots is to prevent sand from coming into your liner. Now, with a disposal well, we're not trying to restrict what we're pushing out into. So with a liner in the oil industry, they're pulling in from the formation and up, and they're trying to hold back solids, whatever, from coming into the well. With an injection string, you're injecting out. Rather than using something like slots, which are meant to, hold back or stop small particles, what you'd rather run is holes because there's less friction associated with them, higher injection rates. So you run a pipe with holes in it, and then you can run a liner hanger. Now, a liner hanger is essentially like the packer. It's a hole in the middle, rubber element on the outside to seal to your casing. And that leaves you open to your formation, which is behind the pipe. Now, we talked about that you're going to have a film from drilling, from your drill mud on the ID of there. And we talked a little bit about, depending on the type of formation, if it's an unconsolidated zone. So let's say it's around here, we have unconsolidated sand. So if, as it comes out of the well, it looks like beach sand, essentially. It's just sand is all it is. There's nothing holding the sand together. It's loose. Doing something where you pull fluid to surface with some of that sand will remove your drill film, your drill filter cake off the ID of your formation so that you get better injection rates after the fact. Now, if it's consolidated, so let's say it's a sandstone, a consolidated sandstone, a carbonate, those kind of things. I've tried this before, trying to pull fluid from the formation to remove the filter cake, but it's not successful. You don't get great results trying to do that. So something you can do on consolidated zones is primarily fracking is the easiest way to do it, where you put high pressure fluid onto the formation until you actually create fractures in your zone. And the fractures obviously open up new formation for you to inject into. So instead of injecting through your filter cake, all of a sudden now you've got a crack here and your fluid can easily go into that crack and then move out into your formation. Now that gets back to maximizing your injection rates on your well. So we talked about cement being the thing you want to design around to limit your risk. For a disposal well, you want to maximize your injection rate. So maximizing your injection rate, if you could only have to drill one well instead of 2 wells or 3 wells, obviously that'll save the company time and money, essentially. So the higher performing the disposal well, the better. Now, when it comes to actually knowing, so let's say you go to inject and you hit high pressure. Well, if it's right after drilling, this is probably the problem, where you have a filter cake on the ID of your formation and you need to get past it or remove it so that you can increase your ejection rate. When it comes to later on in the life of the well, let's say over time, your pressure over time slowly increases. Well, that's going to be a little bit different, similar but different problem to this. Whereas if initially the pressure is high, you can be sure that your filter cake from drilling is your problem. If your pressure increases over time, that means you're plugging over time. And what that comes back to is, okay, what are you injecting for fluid? So let's say in the oil field, there's usually two things that's going to plug your well over time. So those two things are generally oil and solids. So depending on what your facility looks like on surface, if you have a lot of oil and solids carryover, what's going to happen over time is the oil and solids is going to accumulate on the ID of the formation, essentially. And as it accumulates on the ID of your formation, your pressure is going to increase because it's going to be harder to push that fluid into your disposal formation. Now, you can fix this by doing what we talked about before, doing a stimulation to your well, which you're going to have to do. But this will keep occurring if you don't have your facilities on surface running properly. So depending on what you have for filtration, for removing oil, how much settling time you have for your fluid before you inject it. There's a number of ways on the facility side you can go about to fix this problem. But you're going to have to look at the facility, look at the filters. If you are filtering, which I recommend, look at the filters to see what you're collecting. How often do you have to change those filters? Because it might mean a change in facility design to prevent carryover of solids and oil into your well bore. And I've seen this take where the well pressure's up within a month or two, depending on the facility design at surface. With a very basic or no filtration on surface, it can take 1 to 2 months to plug up your well. Well, let's say you're injecting, 1,000 cubes of water a day. Even at 0.1% carryover of solids and oil, that means you're injecting 1 cube of oil and solids into your well on a daily basis. And if you keep doing that for days or months on end, you can imagine how much material and oil you're injecting down into your well that will slowly plug off the well. So you can keep fixing this down here. The problem is if you never fix the surface facility, this will keep happening. It'll keep plugging off your well and pressuring up. Does that make sense for everyone? Just about the plugging side when it comes to both, I guess, on initial drilling and then also on the facility side, plugging over time? Okay. Quite honestly, that covers off a good chunk of disposal wells. Something I can probably go back and talk about is just, I was talking about cementing and the logging that you have to do on a disposal well to make sure that you're keeping your formation fluid inside the zone. So some of the logs that the government in Canada at least makes us run is to make sure that our water we're injecting or the fluid we're injecting is staying within our disposal formation. We get licensed for our disposal formation. And the fluid we're injecting is meant to stay inside this formation. You don't want it migrating anywhere else where it's not supposed to be. You might have oil zones up higher in the well. In potash, we actually inject water down below where the potash is being produced. And you obviously don't want water migrating up into the potash zone. Same thing with the oil zone. If you have oil production, you don't want the water migrating back up into the oil zone that you're producing from. So there's a couple logs that we generally run, cased hole logs, after we're done drilling our well. And one is a cement bond log. So it just measures how good the cement is behind your casing. They just send a signal out, and if the signal comes back where it shows ringing behind the casing, that means your cement isn't up against the casing, essentially. So that's one log they make you do, is cement bond log, and that just makes sure that you've got a good bond between your cement, your casing, and your formation, to know that you don't have water migration behind your casing. The other log, though, that we're required to do is a temp log. So in your well, you'll send a log down, you measure your temperature from bottom up, you get a temperature curve. It's hotter down, the deeper you go, cooler at surface. You get a temperature profile. And then what you do is you inject, like you would under normal operation, you inject a bunch of water. So you inject, maybe 100 cubes, a couple hundred cubes of water that's either hotter or colder than what you get down at the bottom of your formation. And what that does is change the temperature downhole. So inject your couple hundred cubes, it should be going into your formation. And then you relog with your temperature log. And wherever that water is going, you'll see your temperature curve kick. Temperature and depth. So wherever that water is going, you'll see a kick in your temperature curve, so you know where it's going. Now, where you want to see is your temperature kick inside your disposal formation, because that means that your water you're injecting is going into your disposal formation. But if you have bad cement and the water's coming back up behind your casing and then out into some other formation, all of a sudden now you'll see a temperature kick way higher up in the well. And what that tells you is that you've got bad cement behind casing, and the water you're injecting is actually going into the wrong formation. If you have water going into the wrong formation, then all of a sudden you have to remediate it, which is a very painful, very slow, very complicated process, essentially. So if the temp log shows, let's say the water's actually going into a formation way up the well, all you'll have to do is go into your well, perforate your casing, and then cement squeeze into your casing, and then drill out. And then you've got holes. You got holes with cement in your casing for the rest of your life. Now, when you've got your injection string in your well with the packer on the bottom, one of the ways you make sure that everything is good is you fill up the backside . You fill up the backside of between your injection string and your casing string with inhibited fluid. So corrosion inhibited fluid. And the reason for that is you want to protect your casing string, like we discussed before. So you put corrosion inhibitor, plus what that allows you to do is pressure test between your casing and your injection string. And the reason why you want to pressure test between your casing and your injection string is if you ever get a leak in your injection string or your packer, you want to know about that as soon as possible. If you have a leak, then all of a sudden that means the fluid from your formation, from your injection fluid, can get behind against your casing and over time corrode it. So if you pressure test the backside of your injection string and between your injection string and your casing, then all of a sudden you know as soon as you have a problem. And if you do have a problem, well, it's an easy fix. You move in with your rig, pull out your injection string, pull out your packer, rerun another one, set it, and then pressure test it. And that makes sure your casing is always in good shape or it lasts as long as possible, because that is something you can't remove. Now, remember I said if you have bad cement and you need to perforate into your casing, now all of a sudden, now you've got holes in your casing and you've got cement in those holes. But the problem you have is that getting a pressure test against the holes in the casing is problematic over time. If you've got pristine casing, you're going to get a pressure test every time. If you have pristine casing, you're going to get a pressure test every time. If you have holes in your casing that are filled with cement, all it takes is a little pinhole leak in where that cement is, and you're going to fail your pressure test. Now, if you fail your pressure test, no big deal. You pull out your injection string in your packer. But you run it back in, set a new injection string, a new packer, and you still fail the pressure test. Well, now you don't know when your injection string and your packers failed, which means you're kind of running in the dark with everything. So that means if you want to get rid of that problem and know when your injection string or your packer has failed, you have to run essentially a patch over top of those holes in the casing, which then gets back to if you have holes in your casing, you're going to have troubles knowing whether you have a solid pressure test with your injection string. So the easiest thing to eliminate that is to, let's say, run a casing patch. But all of a sudden now with the casing patch, you're taking your available area and you're going to shrink it a little bit. And then that requires you run a smaller injection string. And if you have to run a smaller injection string, then all of a sudden your injection rates decrease. Does that all make sense? In the end, what you need to know is cementing, very important. If you get a bad cement job, you're in a world of trouble because it's going to cause problems for your disposal well, all the rest of the way down the life of the well. Any questions on that? You know, if you guys asked a few more questions, this would take up more time and I wouldn't have to talk so much. So that kind of gives you an idea of, so on the drilling side, what you're trying to do, just to kind of review everything, when you're planning everything out, is you want to minimize your risk and you want to maximize your injection rate, because those are the two biggest factors. Cost is important, no doubt. And if there's one place that is going to cause you the most risk and the most problems, it is going to be your cementing. And to limit that risk, adding something like low circulation material, your sawdust is what we use in Canada because we have lots of trees, fiber, those kind of things will help minimize your risk during drilling. And then maximizing your injection rate goes back to after you're done drilling, doing something to stimulate or make it past your filter cake, your drilling mud filter cake. Long term, to keep your injection rates high, all comes down to your facility. So your facility on surface has to clean up your water enough where you don't have a lot of solids and a lot of oil being injected down your disposal well. Because as soon as you have that, you're going to plug up and your pressure is going to increase over time. So if you have a facility that cleans up your water as good as possible, especially on the oil side, because you don't want to inject a bunch of oil down your well when you could sell that oil. So the more oil you can collect, the better, without a doubt. But if you can get clean water going down your disposal well will last a long time before you have to do anything with, stimulation or anything like that. So that's the major risk factors and what you're trying to do with the disposal well by maximizing your injection rate. When it comes to the actual planning of your disposal well, you really need to figure out, you're first looking at what do you actually look at to size everything, for example. When it comes to your casing string sizes, you work from the inside out. So on a disposal well, your most important string is your injection string. So your injection string is going to determine how much water you can inject. So a smaller injection string is going to limit you to a smaller injection rate. The bigger you go, the more volume you can inject. Once you know the size of this injection string, that will determine the size of your casing string. And depending on how deep you're going, you may need to run multiple casing strings. So if you know your injection string is the most important because it's going to dictate how much fluid you can dispose down inside your well. Once you know what you're trying to get for a disposal rate, you can size your injection string. Once you have sized your injection string, well, then you start sizing your casing strings. And that will determine the structure of your well, essentially. So you size your injection string, that sizes your casing string, sizes your surface casing string, because everything has to fit inside the other one. So injection string, let's say, is 3.5. Okay, your casing string is going to have to be 5.5, and your surface casing is going to have to be 8 5/8, essentially, because everything has to fit inside. The injection string has to fit inside the production casing, which has to fit inside the surface casing. So if you can figure out your injection string, that will dictate the rest of your well. It becomes a lot easier. Now, when it comes to actually picking your disposal formation, and I guess I probably should have covered this off beforehand, but how do you actually pick a disposal formation? Well, the zones that'll take water the best are the thickest, most porous zones. So if you don't want a thin zone, you want a thick zone. It's going to take more water. When it comes to porosity, you want something that's very porous. You don't want something with small holes. You want something with bigger holes. Something that's porous and thick is going to be your best injection zone. The zone you want to inject into will probably be a water zone, a salt water zone of some sort, as opposed to an oil zone as well, just because you don't have to push against anything. So those are kind of the things you're looking at when your disposal formation, essentially. The thicker, the more porous, the better. And then your injection string is going to determine everything else going back on the sizing. Is there any questions on that? I guess I could give a little bit of real world examples from where I am. Oh, yep. Repeat the main, question is, could you repeat the main purpose of injecting? So essentially, why do you have a disposal well in the first place? Well, I'll go to the two industries that I've dealt with. One, the oil field, and the other potash. So in the oil field, when we're making oil, you get water that comes with the oil, essentially. You've got to do something with that water. That water that's coming out of the formation is not fresh; it's salt water. So if you're getting salt water out of an oil well, you've got to do something with it. Now, I know offshore, I believe they clean it and then inject and then just dump it into the ocean. Which is an option because, well, it's right there essentially. Where we are in Canada, we're a long ways away from the ocean. where we produce oil. So you got to do something with that water. Now it's salt water, so you can't put it on the land or use it for anything. Otherwise, it'll, salt water kills. So we have to do something with the salt water essentially. So the easiest, cheapest way to do it is to inject it into a deeper formation and get rid of it. On the potash side, what happens in potash is you get water coming into the potash zones. Depending on the type of potash mine, some are conventionally mined where people actually go under the surface and bring it out. The other type is where they inject fresh water and that dissolves the potash, they bring it to surface. But during their operation, essentially they get a saltwater brine that they need to do something with. Same problem, you can't really do much with it and you just need to get rid of it. So in that case, you drill a well down into your disposal formation and you just dispose of it. Those are the primary purposes for a disposal well. There's other things you can dispose of, but primarily you're looking at water, salt water. If you have fresh water, you can do something with it, but with salt water, you just need to get rid of it. Something that's cheap and easy to do. Any other questions? Yes, the saltwater could be treated. Saltwater could be treated. It really depends on the volumes you're dealing with. So just to give you an idea of like in potash, they'll have wells injecting 7 cubic meters a minute, day in, day out. So the problem you have is volume. You could take the salt out and then sell the salt essentially, but these potash mines have so much potash and so much salt that they can't do anything, or it's not profitable to do anything with the saltwater brine. And when you're talking about 7 cubic meters a minute or 420 cubes an hour, day after day, that's a lot of water they need to do something with. In the oil field, typical disposal well around here might do 1,000 cubes a day of volume. So that's the same thing where you have a lot of volume of salt water you need to do something with. Question was, what should I do for lost circulation problems that will not plug the well screens and reduce water well performance? So the most important thing, so if you have lost circulation while you're drilling, the most important thing is fixing that and then worrying about the problems it caused later. So if you have lost circulation problems while you're drilling, the drilling rig costs a lot of money and the drilling rig is sitting there whether you like it or not. So fixing it however you have to with whatever lost circulation material you have, whether it's fiber, whether it's other stuff, do that because you need to fix your lost circulation materials. So lost circulation is if you're drilling and all of a sudden you start getting losses into a formation. Losing all your drilling fluid is bad. You need to heal those losses as quickly as possible because the drilling rig is the most important. So there's nothing you can really use that's going to, say you have disposal or lost circulation issues in your disposal zone. Are you going to have to deal with that after the fact? Yes, but getting the lost circulation problems fixed ahead of time is the most important thing. Now, when it comes to actually dealing with the lost circulation issues after the fact. So now all of a sudden, let's say you've got a bunch of lost circulation material down inside your zone. Well, that comes back to what kind of zone you have, whether it's consolidated or unconsolidated. So if it's consolidated, if it's unconsolidated, like I said before, something like a foam swab, something to bring all that material in that's going to carry would be the way to go about it. But if it's a consolidated formation, you're going to have troubles, especially if it's really thick. You're going to have troubles getting enough rate to get all that stuff out of your well, in which case I would look at something like fracking just to bypass it, essentially. Yeah, when it comes to the amount of salt water, that's the problem, is just the amount that we have to deal with. Is it's too hard to treat or too hard to take the salt out before doing something with the fresh water. I guess where you live probably has a lot to do with it. In Western Canada, where I live, there's lots of fresh water. We have fresh water everywhere. You drill down 50 meters below surface, pretty much anywhere around here, you'll hit fresh water. So having fresh water is not a real issue. And the salt water is problematic, so we just get rid of it, especially with the volumes we have. Yes, Bahrain. I'd be interested to. I've never actually been to Bahrain. I've been to the United Arab Emirates one time. Um, I have a feeling that a lot of your water, that salt water that comes out of your drilling operations or your production operations in the oil field, probably goes into the ocean, but probably depends on how close you are to the coast as well. So that's me speculating more than anything. What are the alternatives to discharging offshore oil and gas exploration and production waste into the ocean? Well, essentially, and I'm not as familiar with offshore. I'm 1,500, 1,700 kilometers from the ocean, so I haven't dealt with offshore for the most part of my career. You can do a disposal well offshore as well. There'll be formations under the ocean that you can inject into. It's just an added cost. It'd be interesting. I got a feeling that depending on which jurisdiction and where you are in the world, they probably got slightly different governmental oversight on what you can do with how clean the water has to be before it goes back into the ocean, or whether you've got to inject it into a formation, essentially. So the same process can be done where you just inject it into a formation underneath the ocean floor. Anybody else got any questions? It's kind of a whirlwind today, and quite honestly, it's kind of nice to talk in front of people rather than a computer screen. It's sometimes easier to make sure everyone's following along, or even explaining things, interacting with the audience, I guess. But if anyone has any other questions or comments, feel free. I'm going to attempt to post this on YouTube for anyone that wants to go back over it. I also have some other videos. Quite honestly, it's the subjects I talked about today, but in shorter videos. So they might be 4 or 5 minute videos. They're on YouTube. If you just search for Dustin Newman or Hilltop Disposal, you'll find some of the videos I've done. I think there's about 10 up there that cover off the different topics that I covered today, but in smaller chunks, 4 or 5 minute chunks each. Everything from designing a disposal well to all the way down to completion, stimulation facility, minimizing risk, maximizing injection rates. All those are on there. And like I said, they're in a little bit smaller chunks, so sometimes that's a little bit easier to digest rather than having everything in an hour continuously. So. I guess if anyone has any questions about Canada while we're at it, I was looking up Bahrain because you guys are quite a ways away from me, and learning a little bit about your country, which is, I've never been there obviously, and so it's kind of interesting to learn about some place that's a long ways away from here. So yeah, we get snow here 6 months of the year, so it's a long winter. And it never snows in Bahrain. Like I said, I've been to United Arab Emirates and it was way too hot for me. I don't know how you guys deal with your plus 40 temperatures. Yeah, I'm probably better off in the wintertime most of the year rather than dealing with my plus 40 all the time. So anyhow, if there's no further questions, I'll end it there. Thank you for attending. If you have any follow-up questions down the road or need some clarification, just feel free to send me an email. I believe that, well, I'm not even sure how to say your name, quite honestly. Ibtisam, I don't know how, but anyhow, she'll have my email address and you can fire me off a question if you have any questions. I actually don't have Instagram. With a face like this, I probably don't belong on Instagram. I'm on YouTube and I'm on Twitter. My Twitter handle is @DustinNewman. On YouTube, you can find me at, if you search for Dustin Newman or Hilltop Disposal. Like I said, I got a bunch of videos there. So.
Since no one has any questions, I just want to end it by saying thank you so much, Mr. Dustin, for your time. It was a very informative session. It's a new concept for a lot of us, but it was very nice, very informative. I really liked it. So yeah, I want to thank you again for your time and for your information.
Yep, for sure. Thanks for everyone attending.
Thank you.